Now let's discuss about compensated pendulum. As we have just now seen in the previous article that if temperature of pendulum clock increases, its pendulum length also increase, and due to which clock will start losing time. Now based on the same phenomena, such pendulums are made in which the time period does not change with temperature, or you can say these are pendulums in which time period does not change with temperature. You might be feeling that how it would be possible, because if there is a pendulum, certainly its time period depends on its length, and if temperature changes, the length will change, so time period must change. But there can be some different kind of geometrical structures which can be made in which time period does not change with temperature. One or two I'm going to discuss here. Like one is what we call triangular frame compensated pendulum. In such a pendulum, we use three different bars connected in a triangular manner like this. Say this of length L1 and these two of length L2. And the material are also different. This is made up of such a material of which the coefficient of expansion is alpha 1, and for these two bars coefficient of expansion is alpha 2. And on this pendulum a bob is suspended such that the pendulum is hinged at this point and it is allowed to oscillate about this point. Now in this situation, when the temperature increases, all the three rods of length L1 and L2 will increase in length, but due to increase in length of the upper rod, the ends A and B of the rod reaches to points B dash and A dash, and due to this, these two corners will also shift to this point, and slight increase in second bar and third bar will also take place, but as alpha 2 is considered less than alpha 1, it would be expanded in such a way that finally there won't be any change in the position of pendulum bob with respect to the starting point. Only if the rods of length L2 and L2 will change, the bob will certainly move down. But here in this situation, as the upper rod is also expanding, the effective point which the bob is suspended will also move up. So overall effect on the vertical depth of the bob from the hinge will remain unchanged. So in this situation, when such a pendulum will oscillate on varying temperature, its time period will remain constant. In such pendulums, the only challenge is to consider a strong relationship between alpha 1, alpha 2, L1 and L2, such that the structure will be made in such a way that its vertical altitude of the triangle will not change with the temperature. Similarly, there is another compensated pendulum qualitatively we can discuss, that is Mercury tube compensated pendulum. In such a pendulum, we consider a rigid bar which is hinged at its topmost point, at the bottom of which a pendulum bob is suspended, and this is allowed to oscillate. But in such a situation, when temperature increases, the length of this rod will increase and temperature increment will result in increase in time period. Now to compensate the effect of this increase in period, we just connect a test tube, a narrow test tube along with the length of this tube, and we fill mercury into it. The advantage of using this tube is when temperature increases, the center of mass of this pendulum rod goes down, the bob also goes down, but due to increase in temperature, the level of mercury goes up. So we can state, as mercury is quite dense and its mass is also significant. And as its level is going up due to rise in temperature, if we talk about the center of mass of Mercury rod and the pendulum bob, the Mercury is considered up to that level such that the height of center of mass from the hinge point will remain constant with temperature. Even if we increase the temperature, the rod and bob will move down, but Mercury will move up. So it can be managed in such a way that center of mass of the system will remain at rest. So this will also act like a compensated pendulum.